Okay, going to be working out the solutions here to 114, calculating limits. So this is a really important section. Lots of things to learn here about the algebra that's going to be involved in this course. We'll start off here with the first one though. It says, given that you have that the limit as x approaches 2 of f of x equals 4, you're also given the limit as x approaches 2 of g of x equals -2, and the limit as x approaches 2 of h of x equals 0. Figure out all these other things. So part A wants to know what the limit as x approaches 2 of the quantity f of x plus 5 times g of x is equal to. All right, so we're going to be using some of these limit laws in here. First of all, if I have a limit of a sum, I can split this up into two limits. So I'm going to do this. So I've got two limits here now. By the way, that's multiplication right here, 5 times g of x. And then another limit law says that if I have a constant in front of the function, the constant can come out in front of the limit. So limit x approaches 2 f of x plus 5 times the limit as x approaches 2 of g of x. And now I just go back to what was given. I know that this limit right here is this, so that's just 4, plus 5 times the limit is x approaches 2 of g of x, which we know is -2. So 5 times -2. So 4 plus 5 times -2 is -6. And that's pretty much the gist of it. I think you can probably handle the other ones. Just be careful on part D. Oh no, not D. Part E. You're going to get division by 0, and that means that you can't do it, which means the limit does not exist. Okay, so number 2. They give you a graph. So it looks like I might have to draw this. Okay. The graph of f and g are given. So, you know what, I think I'll do this without drawing it because you have it there. Just do part A. Wants to know the limit as x approaches 2 of f of x plus g of x. Okay, so what I'm going to do is I'm going to break this up into two limits using the limit laws. And now I'm going to go look at the f function. I'm going to figure out what happens as x approaches 2. And I can tell from that, if you look at it, here's 2, it goes like up, and there's a circle, and comes down, then it's got a point here. So as you approach 2, remember, we're looking from the left and from the right. We're approaching this way and this way. You can tell that the y value is approaching 2. Doesn't matter what's happening at 2, right? So it looks like it's approaching 2 there. So this is equal to 2 plus, now you do the same thing for the g function. And for the g function at 2, it looks like it does that. So at 2, it actually is that point right there. So as you approach from the left and from the right, you're both sides are going to the value of y equals 0. The fact that there's a dot there doesn't matter. There's not a dot in the book, but since there's not a hole, that means there is a dot. So it looks like the y value is approaching 0, so this is just 0. So the answer is 2. And I think you can do the rest of them the same way. Again, there's really not a lot involved with those. All right, we'll move on to number 5. I'm not trying to rush through these, but there's a lot of work that needs to be done on these later problems, so 5. All right, evaluate the limit and justify each step by talking about the limit laws. So limit as t goes to -2 of t to the 4th minus 2 over 2t squared minus 3t plus 2. All right, so like I do with all limits, I'm just going to try and check to see what happens if I do a direct substitution. If I just replace -2 into all of these, let's see what we get. -2 to the 4th power minus 2 over, now in here, 2 times -2 squared minus 3 times -2 plus 2. And this equals, let's see, 16, -2 times -2 times -2 times -2, minus 2, no, minus 6, minus 2, over, let's see, -2 squared is 4, and times 2 is 8, so we get 8, and then -3 times -2 is plus 6, and then plus 2, which is, let's see, 14 over 16, which is 7/8. So it looks like I'm not getting any problems here. I'm not getting division by 0 or anything like that. So that's the answer. Now they want you to talk about the limit laws. Basically, what I'm doing with the direct substitution is I'm doing the limit on the top and the bottom separately. And then once I do it on the top, I do just a direct replacement. And on the bottom, you could split it up into 3 different limits. In other words, you could do this. Limit, you don't have to write all this down. It's just to show you what the limit laws allow you to do. You're doing the top over the limit of the bottom. And I should have that in parentheses. 2t squared minus 3t plus 2. And then you can split this up into 2 limits, the limit of this minus the limit of 2 times that, or sorry, minus, trying to avoid having to write all this down, but I guess I'll be thorough. All right, t to the 4th, and then I'll say plus the limit as t goes to -2 of -2, and then over, and then you'd have 3 limits here, okay, one for each of those, which I'm not going to write. They would all be down there. And then on this one, you just place it in here and you would get your 16. And then here, the limit of a constant is just the constant. So this will give you -2. So that's why the top came 16 minus 2. And then on the bottom, you do all the replacements and same thing. So that's me actually showing the detail of the limit laws. All I want you to be able to do is the direct substitution and then get your answer, or direct replacement. And I think you can handle number 9. That will hopefully remind you of some of your trig values. And now we get to the most important part. Okay, so number 12. This is where things start getting pretty hairy. All right, limit x approaches 4 of x squared minus 4x over x squared minus 3x minus 4. So let me first start with a direct substitution in here. And when I do a direct substitution, 4 squared is 16, minus 4 times 4, 16. So I'm going to get 0 on top. That could be a problem or it could not. We'll see. On the bottom, x squared, we get 16 minus 3 times 4 is 12, and then minus 4. So we get 0 on the top, and let's see, that's going to be 0 on the bottom. This is bad. All right, this is a bad situation. So that means I'm not done. That means I need to do some sort of algebra or some sort of trick in order to try and make this work. So let me do that. So whenever we see something like this, we try and do some factoring. So do that. On the top, I can factor out an x. And on the bottom, it's a trinomial. There we go. That's the way it factors. And I should have a common factor, because in order to get 0 over 0, something had to turn the top into 0 and simultaneously turn the bottom into 0 when I try and plug 4 in. So you can see this is the common factor that's causing the 0 on the top and the bottom. Now, I am allowed to cancel these two as long as I promise that x will never be 4, which, because we're dealing with the limit, we're talking about what happens as x gets close to 4 and is not actually 4. So that cancellation is a legitimate move. And now what I can do is rewrite x approaches 4. All I have is x on top, and on the bottom x plus 1. And now if x approaches 4, the top becomes 4, and the bottom becomes 5, 4/5. So if we were to try and get our heads around what's happening here, if we were to graph this function, okay, right here, if we were to graph that as a function, we would know that at 4, it would be undefined, okay? We wouldn't have anything there. But as you approach from the left and from the right, you should be getting closer to 4/5. So if this is 1, 4/5 is about right here. So I should have a hole here because it's undefined. But as I come in from the left and from the right, it should be approaching 4/5. Now I can tell all of that by just doing this factoring, canceling, apply the limit, done. And that's it. We're done. So that problem required some factoring in order to do. Let's see what other sorts of algebra we're going to need. All right, let's look at number 14. Limit x approaches -1. X squared minus 4x over, hey, that's the same thing. X squared minus 3x minus 4. So let's see what happens if we replace x with -1 this time. Direct substitution, direct replacement. We're going to get -1 squared, that's 1. -4 times -1 is plus 4. Over, so I don't have 0 on top. Okay, so already things are good. -1 squared is 1. -3 times -1 is plus 3. And -4 down here, minus 4. So we're getting 5 over 0. Now this is a problem that we cannot get around. All right, so at this point, we're going to say that this limit does not exist. And the reason why is because when I plug in -1, I'm not getting 0 on top. I'm only getting 0 on bottom. So when we had the 0 over 0 like the previous problem, when we factored, we were able to cancel a factor. If I factor here, right? If I were to factor, even if I canceled this, then I took my limit as x approached -1. Notice that this is the part that's going to become 0. This part up here is -1, right? -1. And because we're still going to get the division by 0, there's nothing I can do about it, right? So the limit can't exist. And this is where we're having an asymptote. Now we will deal with this in a little more detail later, okay, very soon. But for right now, we're just going to say it does not exist. So to recap, if we get 0 over 0, that's bad. We're going to do some sort of algebra, some sort of trick. If we get some number that's not 0 over 0, then we're going to say the limit doesn't exist. For now. Later on, do something a little different. We'll have to analyze it just a little bit more. All right, let's look at 15. Limit t goes to -3 of t squared minus 9 over 2t squared plus 7t plus 3. So I'll do a quick little plug-in. If I plug in negative 3 squared is 9, I get 9 minus 9, that's 0. Negative 3 squared is 9, times 2 is 18, so I get 18. 7 times negative 3 is negative 21, and then plus 3. And this gives me 0 over 0, and that's bad. All right? So I'm going to do some sort of algebra, some sort of trick. I notice the top is a difference of squares. And on the bottom, we have a trinomial, quadratic trinomial. I should be able to factor this, hopefully. Let's try this. 2t plus 3t plus 1. 2t plus 1. So let's just double check that. Get 2t squared. I get 6 t's, and then another t is 7t, and then 3. That works. But the great thing about this is that we're going to get these two factors to cancel. And now, once they're gone, I can let t become negative 3. Negative 3 minus 3 is negative 6. And then 2 times negative 3 is going to be negative 6 plus 1 is negative 5. And so we get 6/5. Negative over negative is positive. So that one does have a limit, and the limit is 6 over 5. All right, so that one required some factoring. I think I'll let you do 16 on your own. That's also some factoring. Let me look at 17. Or you know what? I'll do 18. You can do 17. Yeah. Limit h goes to 0 of 2 plus h cubed minus 8 over h. Real quick, try and figure out what's going on. If h is 0, that's gone, so this is just 2. 2 cubed is 8, 8 minus 8 is 0. Okay, and then as h, replace it with 0, you get 0 over 0, that's bad. So I've got to do something, right? Well, what can we do here? Can't do the factoring that we did earlier because, I mean, that doesn't factor. This, I guess you could look at as a difference of cubes, but I could also just, figure out what is 2 plus h times 2 plus h times 2 plus h, right? Cube, just go ahead and cube that, and I'll let you work this out, but let me show you what you would do. You do these two together, you get 4 plus 4h plus h squared. That's what happens when you multiply those. Then you multiply by 2 plus h. I guess I'll just take it all the way. And then you go through like this. Okay, so you get what, 8 plus 8h plus 2h squared. Then you go through with this h. So plus 4h plus 4h squared plus h cubed. And then you collect all your like terms together. And I'll put it in descending order. So this is the limit as h goes to 0. Let's see, we have an h cubed. How many h squareds do we have? Plus 6h squared plus 12h's, and then plus 8. So that's just this. Then minus 8, and then all over h. All right, good things are about to happen. These 8's cancel. Once those 8's cancel, I notice that everything that's left in the numerator has an h in it. So I can go limit, h goes to 0, pull an h out, cancel the h. And now, since those are gone, let h go to 0. If that's 0, it's gone. 6 times 0, it's gone. All you're left with is the 12. That's it. So that one was a little different because we didn't factor. We actually expanded out the 2 plus h cubed in order to figure out, in order to get the negative 8 to cancel. And then once we did that, we pulled an h out and canceled out, and we were good to go. 17 should work out similarly. Let's look at 19. For 19, limit x approaches -2, x plus 2 over x cubed plus 8. All right, we'll check real quick to see what happens. Plug -2 in here, we get 0 over -2 cubed is going to be -8 plus 8, that's 0, so that's bad. So I need to do some sort of algebra, some sort of trick, something, right? On this one, I've noticed that the denominator is a sum of cubes. And there's sum of cubes formula, I'll just put it over here. X cubed plus y cubed is equal to x plus y times x squared minus xy plus y squared. That's our formula for sum of cubes. So for us, we have x cubed plus, this is, our y is like the 2, is a 2. 2 cubed is 8. So if we just rewrite this formula, replacing all the y's with 2's, we're in business. So it becomes what, x plus 2, and then it'll become x squared minus x times 2 is 2x, and then plus 2 squared plus 4. And very nice. See this factor and this factor cancel. You're left with the 1 up here, don't forget that. And now let x become -2. So you have a 1 on top. -2 squared is 4. -2 times -2 is 4 again. And then plus 4. So you get 1/12. So I had to factor there using a sum of cubes formula. Let's look at 20. Limit x approaches -1, x squared plus 2x plus 1 over x to the 4th minus 1. Check it for yourself. This is going to give you 0 over 0. All right? So it's a bad situation. I'm going to factor because I recognize some of these things can be factored. This up here is what we call a perfect square trinomial. It's x plus 1 times x plus 1. Okay? And if you multiply that out together, you'll see you'll get that x squared plus 2x plus 1. And then on the bottom, we have a difference of squares. This is x squared plus 1, x squared minus 1. And then we realize that this factors again, x plus 1, x minus 1. So look, I mean, you have to know how to factor, you have to know how to recognize things, or else you're going to be in trouble. Now that we've replaced this with these two, notice that one of these cancels. And now let me just try and do a direct substitution in here. -1 goes in here, -1 plus 1, we get 0 there. Now that may or may not be a problem. -1 squared is 1, 1 plus 1 is 2, so I have 2 there. And then here, I still had this one here. -1 minus 1 is -2. So you get 0 over -4. That's okay, that's just 0. Remember, we can't have 0 on the bottom. If we have 0 over 0, we have to do something. 0 over a number like this, that's just 0, so we're good. Ooh, 21. Okay, now we get some interesting stuff. Limit as h goes to 0. Square root of 9 plus h. And then we have minus 3 out here, and then over h. So check it real quick. If h is 0, this is just 9. Square root of 9 is 3. 3 minus 3 is 0. So we get 0 on top, and then, of course, replace that with 0, you get 0. Okay, this is not good. So we need to do something. We can't factor. We can't do anything that we've done up to this point. So this is where we use a standard sort of trick, all right? And I'm not going to rewrite it, so I'm just going to erase this. If I were doing this like you, I would rewrite the whole thing and start over. What we will do, since we see a square root in there, we are going to introduce a 1 over here. But the 1 is going to be very special. It's going to be the conjugate of what we see there. So it's the same thing we see here, but instead of a minus, we put a plus. If that was a plus, we would put a minus. If we were getting 0 over 0 still. Okay. So I'm going to do that and multiply top and bottom by this. Now keep in mind that that top multiplication is going to go like this. And then the bottom, it's h times all of this, so I'm going to put that in parentheses like that. All right, let's try this. See what happens. Good things are going to happen. This root times this root, that's the same thing as squaring the root, so the root goes away. All I'm left with is 9 plus h. Now this is the critical step. This times this, we're going to get positive 3 times this root. And then when we do the middle one, it's negative 3 times that root. So the positive 3 and the negative 3, they cancel. The middle terms are gone completely. So they've vanished. And now we have the last multiplication, negative 3 times positive 3, which is going to be negative 9. So that's what the top multiplies out to be. That's really nice. And then over, we have h times this. Now notice I'm not going to distribute the h through. Just going to leave this as is, just like it was. And the reason why I'm doing that is because when these two 9s kill each other off, you're left with just an h on top, and you have an h here. And so after these two guys go away, you can reduce this. This is gone, this is gone. This gets replaced by a 1 right here. And so you're really looking at the limit as h goes to 0 of 1 over just the stuff that was here. So root 9 plus h plus 3. And now let h go to 0. And you'll get 1 on top. 0 plus 9 is 9. Square root of 9 is 3. This time, that'll be 3 plus 3, which is 6. So you get 1/6. Ah, conjugate. Okay, I'll let you do 22 on your own. Let's look at 23. Don't forget that conjugate. Sorry. Limit x approaches 16. 4 minus root x over 16x minus x squared. And let's just check it. And this time I'm going to leave myself some space because I know where this is headed. Square root of 16 is 4. So we get 4 minus 4 on top. That's 0. And then 16 times 16 minus 16 squared. That's 0 also. So we get 0 over 0. And now I start to look at what I might be able to do. I see the root here. I think conjugate again. What's the conjugate I'm going to come in here with? 4 plus root x, top and bottom. 4 plus root x. And then we multiply. And let's see what happens. So here to here, 16. The middle terms, this one and this one, are going to wipe each other out. That's the whole reason we use the conjugate. Those middle terms will always vanish. And then the last one, be careful here. Negative times a positive is negative. Root x times root x is the same as root x squared. That's just x. And then over on the bottom, check this out. Do not multiply these two together. It's this thing, right, times this thing. If you multiply those two together, it's going to create a disaster. And now I can almost see I'm going to get cancellation here, except that this has a little more in it than I need. So let me just factor an x out of here. I'm going to pull that x out right there, and I'm going to erase this one and reduce that one. So if I multiply that back through, I would have got back this. And now you see this factor and this factor cancel. That's a 1. Don't forget the 1 up top. So you're going to be taking the limit as x approaches 16. We have a 1 on top. We have the x we pulled out. And then we have the 4 plus root x. And at this point, I will actually let x become 16, so I don't have to write the limit anymore. Root 16 is 4. So we get 1 over 16 times 8. What's that? 8, 80, 48. I can't do simple math. My brain, it shuts down. It literally shuts down. 80 and 48. 128? 1 over 128. There we go. Go back if you need to, and take note of my notation here. I always carry the limit with me the entire time. I'm looking for that in your work also. Carry the limit until you actually replace the x with, or whatever the variable is, with the value. Once you do that, then you can get rid of the limit. Don't be lazy and not write it. Just carry it through. It's like putting periods at the end of sentences. Proper punctuation, proper math punctuation is important. All right, let's look at 25. I like 24. I didn't assign it. You should do number 24. It's worth it. But don't do 24 until you've done this one. One-fourth plus 1 over x over, wait, is that one? Yeah, 4 plus x. All right, check it real quick. What happens when x becomes negative 4? Here we get negative 1/4. 1/4 plus negative 1/4 is going to be 0. 4 plus negative 4 is 0. So we do get 0 over 0. It's bad. And I don't see any factoring I can do. I don't see a square root, so I'm not thinking conjugate. So the rule of thumb here is that if you have this complex fraction, right, fraction within fractions, is to get a common denominator up here. You want a common denominator. So what that means is you have to create the same denominator in both of these. So this one has a 4, this one has an x. 4x is going to be my common denominator. So I need to multiply this one, this first fraction, by a 1. I'm going to make it x over x, so the bottom will become 4x. Over here I'm multiplied by 4 over 4, so that the bottom here becomes 4x. And so we get this. X times 1 is x over 4x, plus 1 times 4 is 4 over 4x. Then all of that over 4 plus x. And notice since these have the same denominator, you can put them together. So x plus 4 over 4x. All of this over 4 plus x. Now you still have a complex fraction, but this one's doable. This one's workable. Notice you have a fraction over this. This is the same as over 1. So you have a fraction over a fraction. Remember, if you take a fraction and divide by a fraction, it's the same as multiplying by the reciprocal. So if I take this and I reciprocate it, flip it, put the 1 up on top, and the 4 plus x on the bottom, like this, then I can get rid of it down here. This is the same, right? Multiplication of the reciprocal is the same as division. So now notice that this and this are exactly the same. They're just flipped. So I can cancel those. And now I just have the limit. X approaches negative 4. I have a 1 on top. I have a 4x on the bottom. Everything else is gone. And now just replace this with negative 4. You get negative, or 1 over negative 16. Very cool. All right. I think 27 is too similar to 18 that I'm not going to do it, but I think you should. It's very similar to number 18. Just expand out that x plus h cubed. Multiply it all out, and then good things happen. Let's look at 28. 28 is a really, really good problem. Limit h goes to 0. 1 over x plus h quantity squared minus 1 over x squared over h. Now pay attention here. The thing that's going to 0 is h. X is just another variable in our problem. So let's talk about what happens when h goes to 0. If that's 0, this is just x squared, right? So we get 1 over x squared, take away 1 over x squared, over, this is going to go to 0. So 1 over x squared minus 1 over x squared, that's 0. You get 0 over 0. This is bad. All right, so we got to work with this. Well, we have a complex fraction, right? We have fractions within fractions. Let's get a common denominator. Well, the common denominator is actually going to be, we need an x plus h squared, and we need an x squared, okay? We need both. So I need to introduce on this one a 1, which is going to be x squared over x squared. And then on this one, I have to introduce an x plus h squared over x plus h squared, like that. Now let's work this out. So the new limit will look like this. Limit h goes to 0. X squared times 1 is x squared over the common denominator minus 1 times this. So I'm going to put this all together now. 1 times this is this. All over your common denominator, which is x squared times x plus h squared. But all of that over h. Okay. So you put these two together and you get this. And then that's all over h. Something good is supposed to happen here. And really what I'm hoping for is that h to cancel. So there's a little more work I can do up here. Why don't I rewrite that top as x squared minus, and then what is this? That's x squared plus 2xh plus h squared. That's what happens if you multiply that times itself. But then you're subtracting it, so it subtracts to each term. So you're going to get minus x squared minus 2xh minus h squared. So that's what the numerator is, over the x squared times x plus h squared, but all of that over h. And I'm even going to put this as h over 1, because that way I'll have some balance. I've got like a fraction over a fraction. And do you see the good news here? These are gone. And then what's still up here, they both have an h. So what I'm going to do is I'm going to rewrite this. But on this one right here, I'm going to pull an h out of both of those. So I factored an h out over this denominator, x squared, x plus h, squared all of this over h over 1. And just to be very, very clear on things, fraction over a fraction, I can flip. This becomes 1 over h here. This is gone. And notice that this h and this h are gone. So what you're left with is the limit, so h goes to 0, of, let's see, the only thing left on top, negative 2x minus h over this thing, x squared, x plus h squared, and that's it, everything else is gone. So now let's let h go to 0. Notice I'm not going to write the limit anymore because I think things are going to be good. H is going to be gone. That's negative 2x over, this is gone, right? This is gone right here. So we just have x plus 0. That's just x squared, right? X squared times x squared is x to the 4th. And I can reduce that out a little bit, cancel out one factor of x, negative 2 over x cubed. There we go. Interesting. All right. I think I'm going to let you look at 43 and 44 on your own. I don't want to give those away, and those are asking you to just think a little bit deeper about some stuff, so I'm going to see how you do with those. I'm going to jump to 49. All right, so the next category of limits that we're doing fall into the strange realm, okay? What you doing here? Students usually have some issues with this. Let me just recap the things that you need in order to do these problems. First, you need to know that the limit as whatever approaches whatever, does not matter what's happening here. If you have sine of some junk over the same junk, and the junk is going to 0. All right, so you're taking a limit, I don't know, maybe you're letting x approach 2 or whatever, and you're working this out. Whatever's in the sign and whatever's under here are identical, whatever they are. And as you take the limit, this goes to 0 and this goes to 0, the answer is 1. It also works the same exact way if it's reversed, if the junk's on top and sine of junk is on the bottom. This is also 1, as long as the junk here and junk here match exactly and they're both going to 0. And then there's another one, limit as whatever to whatever of cosine junk minus 1 over junk, that this goes to 0. So as long as the junk is going to 0, this and this match, then this limit will be 0. This is the big one right here that you need to know, but all these others are consequences of it. So let's look at limit as x goes to 0 of sine of 3x over 3. Notice the way I wrote that. I put the 3x in parentheses. It's understood, but the way it's in the book, they didn't put the parentheses, so they expect that you understand that the argument of this function, 3x, it's trapped in there. Okay. Well, it kind of looks like this first one. We have sine of junk over junk. Is the stuff in here, is this stuff right here going to 0? Well, let x go to 0, 3 times 0 is 0. Yeah, that goes to 0. But we need this stuff to match with this. This needs to be a 3x, and it's not. So we're going to come in here with our magic pen, and we're going to introduce a 3. I can't just slap a 3 here, though, right? Whatever I do the bottom, I have to do the top. So I'm going to slap a 3 up here, right? So really, here's what I'm doing. I'm multiplying by 3 over 3, which is 1. I'm sliding this 3 underneath here and putting a 1 out here. It's the same thing. And now, if we look at this matches exactly this formula. Sine of some junk over the same exact junk. When I take the limit, that junk and that junk both go to 0. The answer is 1. So this right here, when I take the limit, will be a 1. And then I still have a 3 over 1 out here, so times 3. So the answer is 3. Let me do 51, and you can do 50 on your own, but you should look at me do 51 before you do 50. Limit t goes to 0 of tangent 6t over sine 2t. All right, so what happens, let's just check as t goes to 0. If t goes to 0, 6 times 0 is 0, tangent of 0 is 0. So I get 0 on top. 2 times 0 is 0, sine of 0 is 0. So I get 0 on top and bottom, so I need to do something. By the way, I didn't mention that at the beginning of this problem, that if you replace x with 0, you get 0 over 0. So we had to do something about it. Here we have to do something about this also. Now, I'm sure I showed you this in class too, so I'm not too worried about doing this. Sine 6t over 1 times 1 over cosine 6t times 1 over sine 2t. So all I've done is I've taken the definition of tangent is sine over cosine. So tangent of 6t is sine 6t over cosine 6t, and I've split it up into two fractions. So you could put this cosine under here, that would be tangent, but I've pulled them apart. And then this sine 2t on the bottom, I just separated it out here. So if we put all this back together, we would be back here. Now the reason why I do that is so I can identify what the problem is. If t goes to 0, this is 0 over 1. That's not a problem. Over here, cosine of 0, right? If I plug in t is 0 here, cosine of 0 is 1. That's okay. Over here is where we have the problem. Sine of 0 is going to be 0. That's the trouble. So I want to somehow eliminate this from being a problem. And to do that, I'm going to use that junk thing. But up here, I need the same argument. I need it up here. I need a 2t. So I'm going to introduce a 2t on the top and a 2t on the bottom. I'm allowed to do that. Then I'm going to slide this 2t, because it's multiplication, right here. And that leaves me with the 1 up there. So now you can see this, remember, was 0 over 1. That wasn't a problem. This was 1 over 1. That's not a problem. This is the sine junk. The junk goes to 0. This is now okay. This is a 1. But see, I've created a new problem. This is 1 over 0 now. So now this is trouble. But I'm going to fix that because I realized that this sine 6t over 1, even though it wasn't a problem, if I were to have a 6t here, that would just be a 1. And I can almost make that happen by taking this t, and remember this is all multiplication on the bottom, and just slapping it down here under this right here, t. And so just move it over. And now the only thing you're missing is a 6. So I introduce a 6 on the top and the bottom. And then I slide this 6 down and I put it right here. And that's really just going to become a 1 now. And now everything should work. When I take the limit, since the junk here and junk here match, and this is sine junk over junk, this goes to 1. This we already said was 1. This we said was 1. This is 1/2 now, and this is 6 over 1. And when you multiply those all together, you get 3. Amazing. Okay, let me look at 52. Limit theta goes to 0. Cosine theta minus 1 over sine theta. And if we get theta go to 0, cosine of 0 is 1. 1 minus 1 is 0, so we get 0 on top. Sine of 0 is 0. So we do have a problem here. We get 0 over 0. So I think what I'll do is I'll peel everything apart like I've been doing. This is limit theta goes to 0. I'm going to write cosine theta minus 1, because there are two terms up here. I have to write the whole thing over 1. And then over here, 1 over sine theta. So that's the same problem. And now, where's the problem? This is it right here, division by 0. So it would be really nice if I had what up here? Theta. So if I introduce the theta on the top, I have to put a 1 over theta down here. So that's like a theta over theta, and then I split it over. So this now is going to become 1. This right here is 0 over 1. That's not a problem. But now I have division by 0 again. So is there anything I can do with this theta to make it not be a problem? Well, how about we slide it under here? And now this becomes a 1. And the question is this one of our special formulas? Yes, cosine of junk minus 1 over junk, these match, these go to 0. This right here is 0 times this right here is 1. 0 times 1 is 0. So our answer is 0. All right. The next few actually, I'm going to leave to you. And the reason why is because those really require that you think a little deeper. Well, maybe I'll just do 53. That's it. That's the last one I'm doing. 53. And then the rest of the problems in the section I'm going to let you finish up. Sine 3x, limit x goes to 0. Sine 3x over 5x cubed minus 4x. Wow, okay, so let's let x go to 0. That's 0 on top, and then it's obviously 0 on the bottom, so we have a problem. Do you remember this whole thing about if we could get sine of junk over junk, it would work? Well, how about this? I notice on the denominator, I actually have an x in both of these. So how about I pull that x out and be left with 5x squared minus 4, like that? That's fair, right? And then I'm going to do even better. I'm going to just split this apart. I'm going to look at this as being times 1 over 5x squared minus 4. So if I were to pass this x back through to both of those terms, I'd get back this. So where are we now? This right here almost looks like the formula, except I don't have junk. This junk here doesn't match this junk. I need a 3 down here. I can do that as long as I put a 3 on the top, which I'm going to slap out here, 3 over 1. So remember, this was like 3 over 3, the 3 slid over. This is perfect now. This is exactly the formula. This is going to go to 1, so no issues there. If x goes to 0, this is gone. I just get 1 over negative 4. And then over here, I'd get 3. 3 over 1. And if you multiply straight across, you get negative 3/4. That's it. All right. You'll probably have some questions over that, but that's okay. Hope that helps.